Hello and welcome to the Osterholm Update, a podcast on COVID-19 and other infectious diseases with Dr. Michael Osterholm. Dr. Osterholm is an internationally recognized medical detective and director of the Center for Infectious Disease Research and Policy, or CIDRAP, at the University of Minnesota. In this podcast, Dr. Osterholm draws on nearly 50 years of experience investigating infectious disease outbreaks to provide straight talk on the latest infectious disease and public health threats. I'm Chris Dall, reporter for CIDRAP News, and I'm your host for these conversations. Welcome back, everyone, to another episode of the Osterholm Update podcast. As the rollout of the latest COVID-19 booster shots proceeds, researchers with synthetic biology company Codagenics last week announced promising findings from a phase 1 trial of its live attenuated intranasal vaccine candidate, Covaliv. The findings, presented at the ID Week meeting in Boston, showed that 2 doses of the intranasal vaccine prompted robust humoral and cellular immunity in recipients who had not been previously vaccinated against COVID. While it's still early in the game, the hope is that Covaliv and other intranasal vaccines in development could provide broader and longer-lasting immune responses to the SARS-CoV-2 virus and possibly reduce transmission. Could these vaccines be the tools that finally put the pandemic in the rearview mirror? That's one of the topics we're going to discuss on this October 19th episode of the podcast as we look at the international and national COVID trends. We'll also provide an update on the variant picture, discuss some new findings on long COVID, talk about the FDA approval process, answer an ID query on the timing of COVID booster shots, and examine the most recent flu and respiratory syncytial virus data. We'll also bring you the latest installment of This Week in Public Health History. But before we get started, as always, we'll begin with Dr. Osterholm's opening comments and dedication.
Thanks, Chris, and welcome back to all of you who are part of the podcast family. We appreciate being with you very, very much, and we always welcome your feedback, which has been very helpful to us in understanding how we can better serve the information needs that you have. And for all of you who may be listening for the first time, I hope you find what you're looking for, that, again, what we share with you, which varies quite a bit in terms of content and intent, that in fact is something that you can also find useful. Let me just start out by saying that this week's dedication is one that we've put a lot of thought into, and it's one that is very, very difficult for me. Someone very recently reminded me of a line that I've thought of throughout my lifetime as something of a great perspective, and that is, grief is a love with no place to go. And right now, in the state of affairs worldwide, I can't imagine for any of you that it's not a difficult, trying time. And let me just be really clear about the fact that we can focus on one geographic region, one particular situation, but in fact the world has a number of these very difficult moments. Right now, the group Wise Voter, which tracks conflict around the world, and reports that there are 32 ongoing conflicts ranging from drug wars and terrorist insurgents, ethnic conflicts, and civil war, and then, of course, even wars across borders. And none of us, I think, can for a moment walk away from some of the scenes that we see happening worldwide and not feel the pain of the moment. And as some of you know, it may be because of my own childhood and understanding what fear was all about. Can't help but be very moved by seeing children suffer, whether it's a fear, whether it's actual bodily harm or even death, or in those instances, watching a mother or a father cradle their child as they die in their arms. These are tough, tough times and tough moments. So this week's episode is dedicated to all the children we have lost to the violence that is occurring, not just in one location, but in all 32 of these ongoing conflicts. And we also, at the same time, dedicate this podcast to those working for peace and are putting themselves at risk in hopes of ending this senseless and tragic violence. And finally, we dedicate this episode to everyone who is doing what they can to take care of their friends during this time. Again, we must not have to live in a world where grief is a love with no place to go. Moving on into where we are today, I just want to remind everyone that we're coming upon another milestone in the podcast arena, and that is today is the 148th episode of this podcast that we've done. There have been 142 regular episodes, one special one on Mass, one on Thanksgiving in 2020, one holiday special, which I read the Polar Express to my grandchildren, and 3 live events. And each week when we do these podcasts, we try to give you our best shot. And I'm sure that there have been highlights and lowlights in terms of the 148 episodes. But just to remind you that, we're still here. And as we said before, as long as you want us, we will be here to help you try to get through all of that's happening right now from an infectious disease standpoint, and even considering the other issues that are happening around the world. Now, the other news of the day, of course, and it couldn't be a podcast without that news, is what's happening with our sunlight. I'm telling you, I'm beginning to feel it. Today in Minneapolis, the sun will rise at 7:33 a.m. It'll set at 6:21 p.m. tonight. 10 hours and 47 minutes and 48 seconds of sunlight. It's only going to be 2 more weeks before we hit that moment when daylight savings time goes off, and it'll even be much darker, quicker, earlier in the evening. Got to get ready for it. But December 21st is coming, which will be the shortest day of the year, and then we're back at it again. We're going to get better. Now, in terms of our colleagues in Auckland, New Zealand, particularly those at the Occidental Belgian Beer House in Vulcan Lane, we welcome you back to the podcast. You are experiencing the wonderful gift of additional sunlight. Today, sunrise in Auckland is at 6:32 a.m., sunset at 7:40 p.m. You have 13 hours and 7 seconds of sunlight, and you're gaining about 2 minutes and 16 seconds a day. So we appreciate where you're at. We just wish we had some of it, so please share it with us. In the meantime, thank you again for being with us, and we look forward to a pretty packed podcast today.
Mike, let's start with a look at the international and national COVID data. After several weeks of rising COVID activity during the late summer, early fall, the most recent CDC update shows a decline in hospitalizations, deaths, and early indicators like emergency department visits. What do you make of the current picture here in the United States, and what does the global picture look like?
Well, Chris, I want to start by acknowledging that as the testing landscape continues to shift more and more towards at-home antigen testing, or for that matter, if anybody's testing at all, that the exact picture of COVID in the U.S. has become increasingly unclear. That said, as you mentioned in your question, the data that we do have suggests that COVID activity in the U.S. is currently declining. During the week of October 7th, the most recent data available, 1.4% of emergency department patients were COVID positive, down 40% from 4 weeks before in early September. Hospitalizations are also declining, with 14,509 patients in the U.S. hospitalized with COVID during the week of October 7th, again down 11% from 4 weeks prior. Deaths during the week of October 7th were less than half of what they were in early September, at 549 deaths per week. Though it's worth noting that the percentage of all deaths in the United States that were caused by COVID has not changed much over the past month. So it's possible that this very sharp decline in the number of deaths is at least in part due to delays in reporting. But I want to take a step back and put these death numbers into context. Again, during the week of October 7th, as I noted, there were 549 COVID deaths reported in the U.S. This is less than half of what we were seeing just 4 weeks before that, when 1,244 weekly deaths were reported. Even if that is largely due to delayed reporting, we're still in a much better place than we have been for most of the past 3 years. After a small peak of about 3,900 weekly deaths in January, we've seen weekly deaths remain lower than they have been at any point in the pandemic. It's true that the deaths during the early mid-September peak were more than double what we were seeing in early July, but they are still less than 1/3 of what we were seeing in January of this year, and less than 6% of what we were seeing in January of 2022. During the week ending on September 9th through the week ending on October 7th, the most recent data available, between 2.3 and 2.6% of weekly deaths in the United States have been caused by COVID-19. This is less than half of what we were seeing in January 2023 and less than 10% of what we were seeing in January 2022. Now, let me just make 2 points here. One is, again, I remind all of us, as much as we talk about deaths and these empiric numbers, we can never forget these numbers actually all have faces and souls. And the second point I want to make is that we have to remember that these numbers tell us over and over again, we're past the big surge in the pandemic. We will not go back to what it was like in those first 3 years. We will not see another Delta or Omicron-like event actually hit us in the way that they did. Now, I can't say that we're not going to see some notable increases in cases over time as new variants may emerge or immunity wanes in those who have previously been vaccinated or infected. But again, I feel very confident we are never going to go back to 2020 to 2022. Now, in terms of where we're at looking at wastewater data, just as the testing data is a challenge, we're in a transition period with wastewater data surveillance, and it's also a challenge. Let me just provide a brief update. In previous episodes, we've looked at wastewater data as a leading indicator for COVID activity in the U.S. These data were provided by BioBot in connection with the CDC's National Wastewater Surveillance System. CDC's contract with BioBot was terminated at the end of September, and the CDC has since partnered with Verily, previously known as Google Life Sciences. The information provided on the Verily dashboard is far less comprehensive than the data we had with BioBot, but currently shows that we are experiencing a medium level of SARS-CoV-2 in wastewater with a downward trend over the last 21 days. While this is certainly better than seeing increasing levels of SARS-CoV-2, I am hesitant to read too much further into this in the absence of more detailed data. I'm hopeful that Verily will substantially increase access to data that is being collected from around the country. Now let me move to the international scene. To echo what we've discussed at length in previous episodes, the downward shift in COVID testing and reporting presents a challenge in viewing current global trends. But at the outset, let me say this is a nuanced issue. To put the international numbers into perspective, the WHO reported only 2,846 new COVID cases in the last 7 days, which even in periods of very low community transmission is likely to be a massive underestimation. It's becoming increasingly difficult to paint an international COVID picture as the data become harder and harder to come by. Testing and reporting around the world is at an all-time low throughout the pandemic experience. But from the data we do have, we're seeing overall declines in weekly cases and deaths in countries like Italy, Brazil, Canada, and India. And according to wastewater data from our northern neighbor, over half of Canadian sampling sites have stable or declining viral loads. On the other hand, we are seeing a different scenario play out in Europe. The European Center for Disease Prevention's weekly update showed elevated levels of COVID-19 activity in all ages across Europe, especially in older age groups. Fortunately, the increase in activity has not caused significant increases in hospitalizations and deaths. However, that isn't the case in the UK, where there have been gradual increases of COVID metrics across the board, with cases rising 8.5%, hospitalizations rising 12.2%, and deaths up by 3.5%. The variant picture in the EU remains fairly unchanged, with XBB 1.5, with a few mutations remaining dominant, and we are keeping an eye on the new variant JN.1, which is a mutation of the BA 2.86. So let me share my sense of where we're at on the international level. I think a lot of places right now are like it is in the United States. Lots of transmission. We are seeing a number of cases of COVID, but overall the spectrum is much less severe in terms of illness, hospitalizations, and deaths. My sense is what we're seeing in many parts of the world is similar to what we're seeing here in the United States. Lots of transmission, a number of cases, but a limited number of severe illness, hospitalizations, and deaths. And I guess at this point, that has to be accepted as very good news.
And Mike, what does the variant picture look like?
Well, Chris, in the U.S., we're seeing our first decline in EG5 with the growth of one of its descendants, HV.1. For me, the fluidity of these variants is often less concerning than the risk of evolving lineages picking up advantageous mutations. Again, I remind everyone, I have said for years now that when I look at variants, I assume any new variant is innocent until proven guilty. Now, what does raise our concern of a given variant of interest pushing into a variant of concern category is what are those changes that might somehow impact on what the clinical picture might look like among those who get infected. The red flags to watch out for in circulating variants include increase in transmissibility, more severe disease, for example, increased hospitalizations or deaths, significant reduction in antibody neutralization from previous infection or vaccination, and reduced effectiveness of treatments, vaccines, or diagnostic tests. There are currently no circulating variants that I believe meet these criteria as classified by the CDC, and all I can say is I hope that it stays this way for a long time. I'll touch on BA 2.86, a variant that we've talked about in previous weeks. The trouble with BA 2.86, and don't get me wrong, fewer people getting sick is always a good thing, but without a large sample size to study, we still don't know a lot about any of the characteristics from an epidemiologic standpoint. I do want to mention a great paper just published this week in Nature detailing the many facets of viral evolution in the era of Omicron. We'll be sure to provide a link of this in our show notes. Without getting too much into the weeds with their detailed technical analyses, they go through mechanisms that COVID has utilized to gain mutations and change the way it infects hosts. They discuss how similar selection pressures since the beginning of the pandemic have led to the overall dominance of many closely related sublineages. That's what we're seeing now with a lot of XBB variants with the same mutation. However, they go on to raise several concerns about BA 2.86, non-Omicron variants, and even the possibility of the reemergence of Delta. I want to end here with the closing line of the paper. I quote, "The costs of such surveillance are trivial compared with the harm that these viruses can cause," meaning that we really need to do a much, much more active effort to survey for these variants circulating around the world and to try to anticipate what that may mean for human infection, severity of disease, and protection. I couldn't agree with the authors more here. We really do need much, much better global variant surveillance right now.
I want to discuss a couple of noteworthy items on long COVID. One is a new study by researchers from the University of Pennsylvania that could explain some cases of long COVID, and the other is a recent CIDRAP news story on the undercount of long COVID in children due to the lack of a real definition of what long COVID is in children. So what can you tell our audience about these items?
Well, thanks, Chris. Again, as you noted, long COVID is an important issue, and it's one that we continue to cover as much as we can. And obviously, it sure still leads to a very serious and significant health impact on this country. We're still at a point where we have a lot more questions about the condition than we do answers, but we're slowly uncovering the pieces of the long COVID puzzle, and we're getting closer to seeing a more full picture. I'll first address the study from the University of Pennsylvania that you mentioned, which was published this past Monday. The study included 58 participants who were experiencing long COVID symptoms 3 to 22 months after their infection. 30 participants who had been infected but not experiencing any post-COVID symptoms, and 60 participants who were in the acute stages of their SARS-CoV-2 infection. Researchers analyzed blood samples from all the participants and found that those who were experiencing post-COVID symptoms had, on average, lower levels of serotonin in their blood than those not experiencing post-COVID symptoms. Though other metabolites that the researchers looked at were low in those in the acute stage of their infection, the levels of these metabolites returned to the pre-infection levels after the acute stage, even for those experiencing long COVID. This suggests that the lower levels of serotonin in particular could play a role in causing long COVID symptoms. The researchers also found that some of the participants with long COVID still had viral reminiscences in their stool. This is important because most serotonin is produced in the gut, leading researchers to hypothesize that the viral remnants in the gastrointestinal tract are interfering with serotonin production and causing some of the long COVID symptoms. It's important to note that not all participants in the study who had long COVID had low levels of serotonin. And though low levels of serotonin can certainly explain some long COVID symptoms, particularly memory loss, depression, and other cognitive issues, it is unlikely that low serotonin levels alone can explain all the symptoms of long COVID. That said, we need to keep in mind that with something as complex as long COVID that can present in so many different ways, it is very unlikely that we'll ever find a simple explanation that can account for all the symptoms experienced by all long COVID patients. One thing that makes these results particularly promising in the context of long COVID treatment is we already have an entire class of medications. What they're called selective serotonin reuptake inhibitors, or SSRIs. They can help combat these serotonin level issues. SSRIs do not cause the body to produce more serotonin, but they slow the rate of serotonin reuptake, meaning that they allow the serotonin that is produced to remain in the body longer. SSRIs like Prozac and Zoloft are already widely used to treat depression, and the researchers that conducted this study will be starting a trial to determine the effectiveness of Prozac for treating long COVID. We will keep you updated when the results of this trial become available. The second long COVID-related issue that I want to cover today is the prevalence of long COVID in children. As you can probably tell from my opening, this seems to be a children-related podcast for me. As you mentioned in your question, Chris, this particular study was covered in a recent CIDRAP news article, which we will link in the episode description. The article really highlights the fact that as much as we lack an understanding of long COVID prevalence in adults, we have even less of an understanding of long COVID prevalence and symptoms in children. All the challenges that make long COVID difficult to diagnose in adults are also challenges for diagnosing children. In addition, children often lack the vocabulary to describe their symptoms. Even many adults struggle to explain exactly what brain fog feels like, so we certainly shouldn't expect the children to be able to do this as well. Children also don't have as strong an understanding of how they felt at baseline before their acute infection. A 5-year-old child, for example, that has experienced long COVID symptoms for 6 months likely has very little memory of not experiencing long COVID symptoms and may not realize that anything is wrong, particularly if they don't have the vocabulary to explain how they're feeling. Children also may experience different long COVID symptoms than adults, with recent research suggesting there may be a much higher prevalence of gastrointestinal symptoms of long COVID in children compared to what we see in adults. The bottom line is that we need more long COVID studies that are focused specifically on children. These studies can be difficult to conduct, since so many children have experienced asymptomatic infections or false negative tests due to having lower viral load, which makes it very challenging to find controls for studies. Still, it is critical that we continue to study long COVID in children in order to better understand how the condition presents in children and how often it occurs, rather than just assuming it doesn't happen in children or that it happens the same way as it does in adults. We owe it to our children to find these answers.
As I noted in the introduction, there were some promising findings presented last week on the intranasal COVID vaccine candidate Covaliv. Now, it's early and this was just a phase 1 study, but Mike, what did you make of these findings? And more broadly, what is the potential advantage of intranasal vaccines?
Chris, let me just share my perspective on all of this vaccine work that's going on right now and how absolutely critical it is. There's nothing that would please me more, excite me, give me a great deal of hope than someone to find a vaccine against COVID, or for that matter, even a range of coronaviruses that provides durable, long-term immunity and against the variety of variants or new coronaviruses that arise. So, I'm cheerleader 101 right there. But I think we also have to be very careful, having learned from many of our previous studies on new vaccines, that early and supposedly exciting information doesn't always translate to a final product that delivers what, in fact, we all want to have. And so I know that some will tell you that I'm a pessimist on these early vaccines, particularly the mucosal vaccines, of being any better than the mRNA or chimp adeno vaccines that we have now. But I must say that, again, In this case, I will always assume a vaccine is proven ineffective till it's proven effective, kind of the reverse of what I say about variants. So I do acknowledge that this mucosal COVID vaccine research you just mentioned is important. And as you noted last week, Codagenic presented some positive results from their phase 1 trial of their live attenuated intranasal vaccine, Covaliv. The study was a randomized, double-blind, placebo-controlled dose escalation study in healthy adults who had not previously received an mRNA vaccination. Now, let me be clear here. This is dose escalation. This is not about actually preventing any infections. Patients received 2 doses of the inhaled vaccine, which induce immune responses similar to those we see after natural infection. Now, it's important to note that so far, natural infection has obviously not resulted in durable long-term immunity. In addition, we have not seen that kind of protection even with hybrid immunity. That meaning you've had both vaccinations with an mRNA vaccine as well as having had COVID. So at this point, we have to note that this is very, very preliminary information. The T-cell responses for the study was specific to multiple SARS-CoV proteins known to be conserved across the variants, which is very positive news because T-cell immunity is going to play a huge role. Surely this can help provide additional protection against constantly shifting variants. Covalix is also currently being assessed in a large multinational phase 3 WHO trial, and Codagenics was recently awarded a contract with BARDA as part of the Project NextGen for up to $389 million to continue their research and development of Covaliv. This will include a phase 2 trial of participants who previously received mRNA vaccines and will compare the protection provided by Covaliv and the latest mRNA vaccine. So to answer your question about the potential advantage of intranasal vaccines, there are definitely benefits to such vaccines. They're a needle-free option to stimulate mucosal immunity. They don't require refrigeration, so they can be used in low-resource settings. Additionally, uptake may be higher for those who are afraid of needles or for those who are more comfortable with a live attenuated vaccine, which has been a more established platform than mRNA vaccines. But I also want to urge real caution. We currently only have one intranasal vaccine available, FluMist, which has not proven itself to provide high levels of protection. And while COVID is not influenza, we've seen many, many failures when it comes to nasal vaccines. There's a lot of money being dedicated specifically to nasal vaccines, and I'd hate to see ongoing vaccine research become a one-track minded approach, focusing only on those nasal vaccines. Now, again, I want to emphasize, I very much support this kind of research. I would love it if a mucosal vaccine was effective. But as we've seen with influenza, previous infection or experience with the virus due to either infection or vaccination may very well diminish just how well the virus actually takes the mucosal area and how that immunity then sets up. Again, I just remind us all, if a natural infection with the virus doesn't set us up for mucosal protection long term, why will a vaccine do it? So my skepticism should not be perceived as against this vaccine. But at the same time, I want to make sure we don't hold up all the other vaccine research that's going on. You know, right now, the NIH and CEPI have a remarkable collaborative going on in which they're looking milestone by milestone, as we've laid out in our coronavirus vaccine roadmap, for what they must do to determine what are correlates of protection, to determine, in fact, how we measure durability over time, etc. And I think this kind of research is absolutely essential, and keep going with mucosal vaccines. But I wouldn't, at this point, for anyone out there, tell you that this is the answer for the future.
Mike, back in September, an FDA advisory panel ruled that oral phenylephrine, an ingredient in many over-the-counter cold and flu medications like Dayquil, is largely ineffective as a nasal decongestant. This ruling comes more than 40 years after the ingredient was approved by the FDA, and 16 years after the FDA was told that evidence that demonstrated the ingredient's efficacy was flawed. Now, some have used this ruling to raise questions or even cast doubts on the FDA's process for approving other drugs and vaccines. Is that justified?
Chris, my absolute and short answer is no. This is not a reason to question the approval of vaccines and COVID treatments. The main reason for this is that the over-the-counter drugs, including phenylephrine, are regulated differently than vaccines and prescription medications. Over-the-counter drugs are approved and regulated through the FDA's OTC monograph process, which the FDA describes as a rule book for marketing safe and effective over-the-counter drugs. An entirely different process exists for vaccines and prescription drugs, so it really does not make sense to view this as reason to say that the vaccines, including the new boosters, could be unsafe. Now, let me point out, I do think that there needs to be a major overhaul of the over-the-counter market drugs that we often consume. But this is a very, very different issue than the regulation and oversight of the kinds of vaccines we're talking about here. I also want to point out that while the FDA determined that phenylephrine is ineffective, they still did not find any major safety issues with the drug. This means that while the drug may not have helped many people, it is also very unlikely that it caused much harm. It's also worth noting that the FDA continued to review efficacy studies on the drug for decades, including some studies that were done in the past 10 years. While I wish they could have come to this conclusion that these drugs were largely ineffective sooner, as it would have saved a lot of people money on an ineffective medication, we need to give FDA credit now, at least, for continuing to review the evidence and then making this announcement once they determined the drug was not effective. But let me just add on here that unfortunately this issue about the spillover of what happened with over-the-counter drug regulation and oversight now has on how people perceive the safety or effectiveness of our COVID-related vaccines and treatments. Unfortunately, there was a terrible story in the Wall Street Journal this past week by Alicia Finley. And she basically laid out the fact that we have no randomized controlled trials on the new boosters, and therefore, in fact, we can't assume that they're safe or they're effective. Let me just be really clear here. We are now in a stage of vaccine development and oversight that is similar to what we see with influenza vaccines. I'm not saying they are influenza vaccines, but they're seasonal vaccines, but we know that from year to year, we have routinely changed the specific viral antigens in our flu vaccine based on what is circulating in the southern hemisphere for our northern hemisphere or vice versa. So we are always looking 6 months out of what's happening in the southern hemisphere to interpret what flu might look like in the United States, and we adjust the vaccines accordingly. These are not new vaccines. They're the very same vaccines. They just have slightly different antigens in them. Before we called these boosters in the early days of COVID, we don't really call flu boosters in the sense that this is just the next vaccine adjusted for the new variants. That's exactly what's happening right now with COVID. And I feel very, very confident that the same issues around safety and effectiveness that we've seen with the prior COVID vaccine work, which did undergo major randomized controlled trial studies, which have undergone major safety review, is in fact operative with what we're seeing right now with the new vaccine. So don't worry about the over-the-counter drug issue as it relates to COVID vaccines and treatments. A very important message.
That brings us to this week's ID query. We continue to get a lot of questions about the timing of COVID booster shots. And this week we received an email from Bronwyn, who wrote, "In the last podcast, you talked about waiting to take the flu shot until it was closer to flu season. I'm wondering why that logic doesn't apply to taking a COVID vaccine. It seems that the surge is going down and there may be another surge in the winter-January time period. I have the impression that we won't be able to get another vaccine for at least 6 months, if not a year. So wouldn't it make more sense to wait to take the COVID vaccine so that its full potency would be in effect during the next surge?"
Well, Bronwyn, thank you for a really good question. And I know that there are many other listeners wondering about the very same thing. I do understand your logic here. And if my crystal ball were more clear, it would be certainly something I'd consider. But there are a couple reasons for not waiting on a COVID vaccine. The primary issue is that COVID has not yet become a seasonal virus, meaning that the only way I could define it as seasonal is it occurs in all 4 seasons. We are seeing case numbers rise in the fall. They're dropping now. They may rise again in the winter with a new variant. But the fact of the matter is they're not like the highly predictable influenza seasonal pattern where we can pretty much count on it from potentially late October into February, early March, with the height of the activity most likely to occur around the holiday season. So from that perspective, this is not a seasonal vaccine for COVID because, in fact, we need protection right now. We needed it 4 weeks ago. And it's surely possible we could see activity pick up again in January, February, March, but it's not going to be in the same way that we see surges with flu. So from that perspective, we want you to get your COVID vaccine and your RSV vaccine if you're eligible right now. RSV is likely to last at least several years in terms of protection, and we're beginning to see RSV increase right now. And as I've said before on flu, I would surely wait until we have evidence of flu activity in our communities, because we know that once you receive the flu vaccine, there is anywhere from a 2 to 12% loss of protection per month following vaccination. So if I get vaccinated in August or September and we don't see flu activity till December or January, I may have lost 50 to 60% of the protection from that vaccine during that time. So it is critical to time your flu shot to when activity is going to increase. Is not so critical with COVID because, in fact, that activity is right now and it will be throughout the winter. Let me just say that at this point, I think it is fair to begin to think about vaccinating your kids for flu. We're now beginning to see up to 7 to 8% positive rates in kids in some parts of the country. And right now, for school-age children, I would consider getting them vaccinated. We're still seeing very, very little flu activity in adults, even older adults. So there, I think we can wait, but we may be on the cusp of saying, get in and get your flu shot too. So I hope this helps straighten this out a bit, and the fact that your logic, again, makes a lot of sense. It's just that we see with COVID a picture that does not at all represent a quote-unquote seasonal virus yet. And therefore, you want protection now. You hope you can have protection 4, 5, 6 months from now. And I think you were going to be talking about the possibility in some circles, particularly those at high risk for serious illness, hospitalizations, and deaths, being eligible for an additional dose every 6 months. We're not there yet, but I think that's likely to happen.
So speaking of flu, let's get an update on the latest U.S. flu data. Mike, do we have a sense yet of what this flu season is going to look like? And what about RSV?
Well, Chris, as I just said, as of right now, the flu numbers are looking relatively low. You may know that each year the CDC estimates a national baseline for the percentages of visits to healthcare providers for influenza-like illness. This includes fever and cough or sore throat. They calculate this based on a mean percentage seen in the last 2 years' data from non-influenza weeks. This year, we're looking at around 2.9%, which is slightly higher than last year's baseline, meaning we may not expect to see slightly more illnesses than the seasons beginning in 2021 and 2022. But we can't be certain at this time. The CDC reports week 40, which ended October 7th, at 2.16% of all visits to physicians were for influenza-like illnesses. Now, that doesn't guarantee that they were actually influenza. It's possible, but there could be other respiratory viruses also contributing to that. But regardless, we are still below a baseline for this season. And that means that largely we would not recommend everyone go get their flu shot yet. Now, as I just noted, that, however, we are beginning to see an uptick in kids. That could mean that within the next 2 weeks, we would say, go in and get your flu shots for kids. At that point, from an adult standpoint, if you're accompanying the kids, get your flu shot. We're getting closer to that time when we might expect to see an increase in kids. But at this point, I would say we're still in good shape with flu, relatively speaking. Now, unfortunately, the same cannot be said for RSV. And I fear the trends we're seeing now marks the beginning of a continued and important rise in cases. Since the summer, the U.S. has seen a gradual increase in the percent of tests for RSV, which return a positive result, and in the overall case numbers. The U.S. region showing the most concern is the South, which reports 20.2% positivity in antigen tests and 9.7% in PCR detections for RSV. Other regions report much lower percentages, but still increasing from the week prior. With the newly available RSV vaccines for those 60 and up, infants and pregnant people, I encourage those who are eligible to get their immunization right now. I have mine. I urge you to get yours. Staggering COVID, flu, and RSV vaccines may seem counterintuitive or inconvenient, but I want to underline how crucial it is to maximize your own immune defenses to be prepared for these levels of community transmission. Remember, respiratory illnesses across the board, RSV, influenza, and COVID, are big threats to the health and well-being of many in this country, particularly those who are older. Now is the time to deal with that. If you've not had any of these 3 vaccines and you're eligible, get your COVID and RSV vaccine immediately and follow along with regard to flu activity. And maybe in the next several weeks, we'll be telling you absolutely get in and get your flu shot too.
Mike, as some of our listeners may know, you're currently working on a book about the COVID-19 pandemic. Can you give us an early glimpse of what you're going to cover in the book?
Well, thanks, Chris. Authors usually never want to talk about their books before they're hatched. But let me just say the one that I am working on right now with my co-author, Mark Olshaker, who many of you recognize, also co-authored Deadliest Enemies with me, and our incredible editorial support of Ann Hennigan. And we actually hopefully will complete this book within the next weeks. And it is one that has been entitled The Big One. And it's not really about a historic review of the COVID pandemic, but rather about lessons learned from the COVID pandemic that we should be carrying forward to prepare for the big one. And you say, well, wait a minute, what does that mean? Well, we are describing in this book a scenario that could very easily happen with either coronaviruses or influenza viruses, much, much more impactful kind of a pandemic in terms of worldwide health and economic implications than we've seen with SARS-CoV-2. Think about this. SARS and MERS, 2 previous coronavirus challenges, both killed between 15 to 35% of the people that got infected. Now, the good news is they were not that highly infectious, meaning why there was airborne transmission. We were able to shut down transmission by basically identifying cases and quickly isolating them. That's not the case, as you know, with SARS-CoV-2. But fortunately, and still it's a tragedy in no other terms, only 0.5 to 1% of people who developed SARS-CoV-2 infection or COVID-19 died. Now, there is nothing to keep one of the coronaviruses that could emerge in the future from having the same kind of lethality, or what we call virulence, that is similar to that which we see with SARS or MERS and the infectiousness of SARS-CoV-2. Imagine a virus as highly as infectious as SARS-CoV-2 killing 15 to 35% of the people, as opposed to 0.5% of the people. And so what we're trying to do is prepare people to say, these are the things that we should be learning. What did we learn from mandates? What did we learn from respiratory protection? What did we learn from what we closed in terms of schools or not? And in a sense, it's really our way of going back and saying, these are the lessons we should have learned, could have learned, but haven't. And I think right now we want to gloss over this quote-unquote pandemic because we're done with it. And I can surely identify with that and understand that. But at the same time, we're missing the opportunity to learn from our experience as to how we can be better prepared for the future. So this book is really all about that. And it's probably not going to be always a well-received book because I try very hard just to, tell the truth and, do it with humility, but do it with certainty about the things that we could have done much better and what that means for the future. So we'll keep you posted on the book. I hope that it can contribute to a dialogue about how to be better prepared for the future. And that's what it's all about. Again, the next pandemic is going to be here, which it will happen in a world where my grandkids live. And so for me, this is a labor of love. And to be able to work with Mark and Ann on this book is a remarkable gift. They are very, very talented. And I hope that it can have a positive impact of making our future pandemic responses more effective for my grandkids.
Now for this week in public health history. This week, we're celebrating a major name in vaccine history, as well as the discovery of an important early antibiotic. What can you tell us, Mike?
Well, first of all, I'm really enjoying this new segment, Chris. And this week, we have two really important events to feature. The first event took place 80 years ago today, October 19th, 1943. On this day, streptomycin was first isolated from the bacteria Streptomyces griseus at a lab at Rutgers University. Streptomycin is an aminoglycoside antibiotic that was one of the first effective treatments against tuberculosis. In fact, just months after its discovery, researchers from Rutgers were collaborating with the Mayo Clinic to begin clinical trials. It is still used to treat numerous infectious diseases and is on the World Health Organization's list of essential medicines. Unfortunately, the problem of antibiotic resistance threatens the continued use of this critical treatment, especially for infections facing multi-drug resistance like tuberculosis. An interesting part of the story of streptomycin's discovery has to do with who is credited and therefore who is celebrated, who is on the patent, and who receives compensation. While the story is still a bit murky, it is confirmed that streptomycin was isolated in the laboratory of Dr. Salman Abraham Waxman at Rutgers. Dr. Waxman received the Nobel Prize in Physiology or Medicine for the discovery. Dr. Waxman's name was also on the patent for the drug and received the majority of royalties for its sale. However, more information was brought forth through a lawsuit against Dr. Waxman and the Rutgers Research and Endowment Foundation when a PhD student, Albert Schatz, claimed that he was the one responsible for streptomycin's discovery. Furthermore, a master's student in the laboratory, Elizabeth Bougie, was also integral to the discovery. While student Albert Schatz was successful in his lawsuit, gaining his name on the patent, royalties for the medication, and a medal from Rutgers University, Elizabeth Bougie remained mostly unrecognized in her time. In fact, when the patent was being processed, she was told her name was not important, as she would, quote, one day get married and have a family. Her daughter, a microbiologist herself, was later quoted saying that her mother, and I quote, did research not for notoriety, but for love of science, unquote. This story is one of many examples of the importance of students and trainees in science, as well as often overlooked accomplishments of women in STEM. I must add that this particular event reminds me of how fortunate I am to work at CIDRAP. And I say with great pride, if you look at the 29 professionals that we have working in CIDRAP, 23 of the 29 are women. And unlike what Elizabeth went through, I hope that we continue to foster a very positive and growing environment for some of the very, very best public health professionals in the world, who just also happen to be women. The story that leads well into our second public health history moment of the week, the birth date of Jonas Salk, October 28, 1914. Dr. Salk was an American virologist best known for his development of one of the first successful polio vaccines. In the midst of the world's losing a battle against polio, Salk's vaccines had the ability to save children and adults from disability and death. And yet, he did not use that opportunity primarily for profit and fame. In my book with Mark Olshaker, Deadliest Enemies, I cover one of the greatest quotes of that decade. In 1955, Salk was interviewed live on CBS and asked, "Who owns the patent for this vaccine?" He responded, almost somewhat surprised, saying, "Well, the people, I would say. There is no patent. Could you patent the sun?" He instantaneously became the hero of our country. What I take away from each of these events is perspective on how we understand recognition, fame, and compensation in the wake of incredible discoveries that have the ability to save millions, if not billions, of lives. While names of Nobel Prize winners are lauded and celebrated widely, there is critical work being done by those who aren't publicly recognized or compensated for their contributions, especially those who have been historically marginalized, even kept out of the field of science altogether. Even Jonas Salk himself never won a Nobel Prize, And I understand that love of science doesn't exactly pay the bills. So fair compensation surely plays a role here. But in the spirit of scientists like Elizabeth Budgie, I hope we can all switch our focus from individual notoriety and profiting to the pursuit of discovery for the common good. And I look forward to today's children, future scientists of the world, and to all the great accomplishments they will bring in the field someday.
And just a note to our listeners that you can always send us your ideas for our This Week in Public Health History segment. And also a reminder that we have not abandoned our Moments of Joy segment. So if you have a moment of joy that you would like to share with us and the Osterholm Update listeners, you can share it with us at osterholmupdate@umn.edu. Mike, what are your take-home messages for today?
Well, I actually have 4 of them, not 3. And the first one may come out of left field, but hopefully in a moment it will make some sense. My first takeaway message is, what the world needs now is love, sweet love. More on that in a moment. My second take-home point is that, yes, COVID cases are decreasing in all phases: acute illness, serious illness, hospitalizations, and deaths. And this is really great news. But at the same time, we must encourage all of those who particularly at increased risk of serious illness, hospitalizations, and deaths to be vaccinated with this new dose of vaccine, which will provide some very good protection against the current circulating variants, at least in terms of reducing serious illness, hospitalizations, and deaths. Vaccine uptake is a challenge. It's been hard to get the vaccine. Each week we hope that it gets better, but it surely has been a challenge. If you're looking for pediatric doses, it's even been a bigger challenge, both because of availability, this is an issue, and because there's still so many who should be vaccinated to reduce their increased risk of serious illness who are not getting vaccinated. So please, even with COVID going down, now's the time to get vaccinated. The third point is, get your RSV vaccine right now. If you're eligible, get it. We're clearly seeing RSV activity pick up. I'd hold on the flu for now, unless you're a child. And then I think parents right now, because what we're beginning to see with increasing number of cases there, should clearly schedule their appointments to get their children's flu shot. We may only be a couple of weeks behind in making that same recommendation for adults. But right now, we're not seeing really a community-wide increasing flu problem. And so again, trying to buy as much time as we can with the vaccines, I would wait. But again, that may change soon. And finally, my fourth point is relates to the comments I made about the mucosal vaccine for COVID and the research that's going on. I can only hope that in fact we will see these very highly effective vaccines coming out of this kind of research, and I would welcome the chance that this could be a mucosal vaccine. But as you've heard me say so many times on this podcast, hope is not a strategy. And so we have to understand the importance of a broad base of work activity using a number of different kinds of vaccines and building the kind of research portfolio that helps us identify what are correlates of protection, or what might be durability, how might it stand up against time and new variants. And this is all critical work that has to be done.
And Mike, my guess is that our closing song for this episode is related to point number 1.
Thank you, Chris. You have come to really know me. After that very difficult dedication and talking about the challenges that we have right now in terms of even our public health world with infectious diseases, I thought it was really important to leave us on an uplifted note. And this week's closing song was chosen in light of our dedication and what we're experiencing as a world. And we've used this song once before in episode 93, What the World Needs, on March 3rd, 2022. At that time, we chose that song for the episode in light of the violence that was occurring in Ukraine at that very time. So you're right. What I've chosen this week is What the World Needs Now. Lyrics by Hal David, music composed by Burt Bacharach, and the song made popular by Jackie DeShannon. I think most of you know Dionne Warwick also did a cover on this, and that too became very popular. The song was released in 1965 at the beginning of the Vietnam War, which by itself was a very contentious event in this country. And for one, that this song rose to number 7 in the Hot 100, and in part seen as an answer to how we might look at the pain and suffering of Vietnam. Today, it surely seems a song for the moment. So here it is, What the World Needs Now, lyrics by Hal David and music composed by Burt Bacharach. What the world needs now is love, sweet love. It's the only thing that there's just too little of. What the world needs now is love, sweet love, not just for some, but for everyone. Lord, we don't need another mountain. There are mountains and hillsides enough to climb. There are oceans and rivers enough to cross, enough to last till the end of time. What the world needs now is love, sweet love. It's the only thing that there's just too little of. No, not just for some, but for everyone. Lord, we don't need another meadow. There are cornfields and wheat fields enough to grow. There are sunbeams and moonbeams enough to shine. Oh, listen, Lord, if you want to know. What the world needs now is love, sweet love. It's the only thing that there's just too little of. What the world needs now is love, sweet love. Not just for some, oh, but just for everyone. Thank you again for all of you for being with us. I hope that we're able to provide you with information that's helpful. I hope also we may have provided with this closing some sense of hope for the future in a world that right now seems desperately short on that. So thank you so much for being with us. Be safe. Never forget, all these numbers I talk about are not numbers only. They're people's lives, they're people's faces, they're people's heart and souls. Thank you.
Thanks for listening to the latest episode of the Osterholm Update. If you enjoyed the podcast, please subscribe, rate, and review wherever you get your podcasts. And be sure to keep up with the latest infectious disease news by visiting our website, cidrap.umn.edu. This podcast is supported in part by you, our listeners. If you would like to donate, please go to cidrap.umn.edu/support. The Osterholm Update is produced by Sydney Redepenning, Elise Holmes, Corey Anderson, Angela Ulrich, Meredith Arpey, and Claire Stoddard.